Bidaku pardu tigo bu bidaku.
These might seem to be random stream of sound and shape, yet they have been the main method to study statistical learning during the past 2 decades. In 1996, Safar and colleagues found that 8-month infant could use transitional probability to segment sound streams. Later, research on zebra finches, rats, and non-human primates had showed that animals have statistical learning ability. However, the experiments are mostly conducted under supervised procedure where the animals get feedback or reinforcement. Previous study has also shown that the newborns had certain statistical learning ability, but their sensitivity towards transitional probability will not emerge until 5 months old. Based on that, Santolin 2016 conducted an unsupervised test on new hatched chicks with shape sequence. Santolin reported that the chicks show novelty preference for unfamiliar sequence. That's proof that statistical learning might be fully operating at the onset of life. Wood 2019 recognized the importance of Santolin's research, but also pointed out some limitations, including noisy measurements, small effect size, and high analytic flexibility. To address these issues, Wood redesigned the study with several changes to the method, targeting larger sample size, longer training and testing time, and less disturbance. 12 chicks are used in the experiment. Instead of placing the chicks between 2 screens like Santolin did, Wood designed a chamber to isolate the chick from the outside world during the experiment. The chicks were exposed to repeated visual stimuli consisting of 4 shapes: cross, X-shape, circle, and triangle. The shapes are paired into fixed groups of 2, circle followed by X, or triangle followed by cross. The transitional probability is 1.0 within a group and 0.5 between groups. Different from Santolin's experiment, Woods wants to ensure that the chicks are sensitive towards transitional probability instead of simply remembering the shapes. Therefore, a shape recognition condition is also created. 4 new shapes are presented, either paired or random. Additionally, the learning and testing time was expanded to 12 days instead of 2 hours. During the test period of transitional probability condition, the chicks are shown unfamiliar paired shapes or random sequence. According to Santolin, the chicks tend to approach the screen that display the novel sequence first and spend more time there. However, Wood found that the chicks' behavior in transitional probability condition has no difference with their behavior by chance. Rather, they show novelty preference for shape recognition condition, which suggests that the new hatched chicks have some statistical learning ability but fail to encode transitional probability. In order to rule out the possible difference that result from different method of study, Wood then repeat the exact same experiment by Santolin, but the outcome still couldn't prove that new hatched chicks are sensitive towards transitional probability. Wood concluded that due to the limitation of Santolin's experiment, the result might be inaccurate. The new experiment agreed with the result from previous studies. Human and animal infants are not able to encode transitional probability, but they do demonstrate other statistical learning abilities. Wood suggests that detecting transitional probabilities is a complex process, requiring longer working memory and the ability to predicate, as newborns might not be capable of doing so. However, further experiments are still required to explore what statistical learning ability are operational at the onset of life.